your physics teacher, and I'll be walking you through your journey in physics today. That is Physics 101, and that is the basics and fundamentals of physics. So the first one, we are going to consider what we call physical quantities, okay? Physical quantities. Physical quantities. So when we talk of quantity, a quantity, right? A quantity is anything, right, that can be measured at a lab or can be expressed using mathematical means. And so the measurable property of a material that can be expressed in a numerical form with unit is what we call the physical quantity. And so we have so many things that we consider. We say so many things. We give reference to so many things. Example, if I say 5 meters or 2 miles or 30 kilometers. Now, when I say that, I said 30 kilometers. What is attached to it? The moment you hear of kilo, it means I'm talking of a distance. But if I say 30, 30 is just the numerical value, but the kilometers is the unit attached to it, and it points you to a particular direction, more or less a particular quantity that I'm referring to. Now, if I say 10 degrees, then 10 is the numerical value, but the degree is that of temperature or that of an angle, all right? Degree Celsius, degree Fahrenheit, okay? Or Kelvin, degree Kelvin, okay? Then I'm referring to temperature. But if I say degrees, I'm talking of the measure of an angle. But if I say 30, 30 is just a number, and that is the numerical value. Now we have 4 main types of quantities, but most people or most of the books limit down to just 2. However, the first one, so types of quantities, we have the first one, that is the base or fundamental quantity. The base of fundamental quantities. Right now, what is a base quantity? Now, a base quantity is a quantity that cannot be derived or obtained from any other quantities. So they form the building blocks of all quantities. An example is mass, time, okay? Time, we have distance or length. Now, these are all base quantities. But let me tell you something. Base and fundamental. Now, all base quantities are fundamental quantities, but not all fundamental quantities are base quantities. And let me explain. Now, looking at these 3 that we have here, so mass, time, and length or distance, they are base quantities, right? They are also fundamental quantities. But quantities like temperature, luminous intensity, amount of substance. Now, 1, 2, 3, okay, 4, 5, 6. Luminous intensity, amount of substance, and current. Good. Now, all these are the fundamental quantities, but these three are base quantities. However, most of the textbooks or most of the reference materials put them together. Now, why do we say that these are base? Mass, length, and time. Now, in mechanics, mechanically, these are the ones that hold. Mass, time, and then length. They run through all. But these ones, they are somewhat limited a little bit. That is temperature, luminous intensity, amount of substance, and current to certain aspects. But when you consider the others, every time you consider a concept in physics, you always come across these ones. Mass, time, and length, especially in mechanics. Motion in one dimension, motion in two dimensions, motion in three dimensions. You come across all these ones. All right, so I just wanted to make some small clarification over there. So, base quantity is a quantity that cannot be derived or obtained from any other quantity. So they are on their own. I hope you understand. Now the next one, the next type. So I'm gonna rub this one off. So we have the base quantities that is well established, and these are the examples. We have mass, time, distance, or length. Have temperature, luminous intensity, amount of substance, and then current. These are the fundamental quantities. Okay? Now the next one is the derived quantity. Okay? Derived quantity. And so we have looked at derived quantity. So B, derived quantity. Now, as the name even connotes, derived, okay? Derived, it means it's obtained, okay? Derived quantity. So a derived quantity is a quantity or quantities that is obtained as a result of combining two or more base quantities. I take it again. A derived quantity is a quantity obtained as a result of the combination. Now, by combination, I'm talking of either division or multiplication in order to obtain that quantity. Okay, so a typical example of a derived quantity is area. Area is equal to length multiplying length. Right? Another one is volume. Volume is length multiplying length multiplying another length. Now, why am I using length? Now, if I use breadth, if I use height, they are all considered as length. Okay? So in order not to confuse you, we can equally put down length times breadth times height. That is volume. The next one is density. Density, which is expressed mathematically as the mass per unit volume. Okay? Mass divided by the volume. Now, when you look at it, we have a base or fundamental quantity. This is a derived quantity. So when we divide a base quantity by a derived quantity, we still get a derived quantity, right? Two fundamental quantities multiplying gives you a derived quantity. 3 fundamental quantities multiplying gives you a derived quantity. And so, again, a derived quantity is any quantity obtained as a result of the combination of 2 or more base quantities. I hope you understand. Now, the next type of quantity is a scalar quantity. A scalar quantity. Now, so the second part, so scalar quantity. Now, a scalar quantity is any quantity which has magnitude but no direction. Magnitude but no direction. And so when we talk of magnitude is the measure of that particular quantity that we are talking about. And so if I say, and if you recall, I made reference in my opening statement that we have 10 meters, 2 miles, 100 kilometers, 30 degrees or 40 degrees Celsius, 40 degrees Fahrenheit, and stuff like that. But then this is where the clarity comes in. And so has magnitude but no direction. So if I write 10 meters, right? So 10 meters, this one, 10 meters what? When I say 10 meters, or 10 centimeters, or 40 miles, or 25 kilometers, or 25 degrees Celsius, or 75 degrees Fahrenheit, okay? Now, when I say that, then if I don't indicate any direction where it's heading, then it becomes a scalar quantity. I hope you understand. And so a typical example of scalar quantities, all right? So if I say 10 meters what? This is just a value that we are saying. So the magnitude is expressed, but there is no direction attached to it. And therefore it makes it a scalar quantity. So example of scalar quantities, we have distance, area, right? Distance, area, we have mass, we have time, okay? We have speed, and a whole lot of them, just to mention a few. All these are examples of scalar quantities. Why? Because they have magnitude, but they do not have direction. I hope you get it. Now, the last one, which is, let me put it down here, is a vector quantity. Vector quantity. Now, a vector quantity is gives an added information to the quantity or the value that we are mentioning. Don't forget that we said that a physical quantity is the measurable property of a material expressed in a numerical form or numerical value with unit. Now, if we are having the numerical value with unit but do not know where it is heading, then it becomes a scalar. But if we know the numerical value and we know which direction it's taking, then it becomes a vector quantity. So take a guess. What do you think a vector quantity will be? The guess is as good as mine. So a vector quantity has both magnitude and direction. Okay? Has both magnitude and direction. And so, going back to the previous example, I said 10 meters. But if I say 10 meters north, now we know, where I'm heading to, right? If I say 5 miles east, then you know what I'm talking about. It's not any direction, not anywhere, but in east direction. So if you move to the west, you have changed the direction I'm pointing you to. I hope you understand. And so 10 meters north, 10 meters south, 10 meters northeast, 10 meters southwest. All right? When I say all these things, then I am giving you a particular direction. And all these, I'm using these meters. I'm using length because that is very, very, very easy to relate to. Now, as we progress, I'll top it up with other quantities as well. And so, A typical example of vector quantity includes that of so this will be displacement, okay, example displacement, velocity, just mention a few, acceleration, all right, acceleration, just to mention a few, acceleration, okay, and so that is it. So displacement, velocity, acceleration. We also have force. Okay, we also have force, we have torque. Okay, all these ones are examples of vector quantities. I hope you get it. And so to wrap it up, a physical quantity is any quantity. We said that a physical quantity is any quantity that has a measurable property which is expressed in a numerical value with unit. Then we said that we have 4 main types, right, of physical quantities. We have the base quantity or the fundamental quantity. Sometimes they are used interchangeably, but they all form the same. The only distinction is that some of the base quantities, all base quantities are part of fundamental quantities, but not all fundamental quantities are base quantities. And we established that a base quantity is a quantity that cannot be expressed or obtained from any other quantity. Examples include mass, time, length, right? Mass, time, length, current, luminous intensity, amount of substance. Okay? These are all fundamental quantities. Now, the second type is a derived quantity, and we said that a derived quantity is any quantity that is obtained as a result of the multiplication or the product of 2 or more base quantities, or the division of 2 or more base quantities. We cited examples such as area, volume, density, even force. Is also because force is the product of mass times acceleration, or mass multiplying acceleration. Now, the other type, the third type of a physical quantity, that is a scalar quantity. Now, a scalar quantity is any quantity that has magnitude but no direction. And we said that some examples of a scalar quantity is distance, mass, time, just to mention a few. Now, as we progress, we'll be using all these, and then I'll be pointing them out. Which of them are scalar, which of them are fundamental, which of them are derived quantities. I hope you understand. And then the fourth one is the vector quantity. Now, we said a vector quantity is any quantity that has both magnitude and direction. To further break it down, vector quantity gives additional information to whatever we are talking about. And we made reference to displacement. Now, displacement is the length or distance between 2 points in a specified direction. But distance is the length between 2 points. We don't know what direction. That is why it makes this distance becomes a scalar, but displacement becomes a vector quantity. We also talked of speed. Now, speed is a scalar quantity because speed is the distance per unit time. But then velocity is a vector quantity because it gives us the specific direction in which the body or the particle is heading. So that one is displacement per unit time. And the mere fact that we have displacement, which is a vector quantity, all right, the vector quantity over there now makes velocity a vector quantity. Acceleration too is also an example of a vector quantity, just to mention a few. I hope you have learned so much today. I wouldn't want to proceed, but watch out for the next video as we talk about scientific units and measurements. Units are very, very important because we said the numerical value with a unit. So we'll be looking at the unit of these quantities and how these numerical values are expressed for easy understanding. Have a great day. I'll see you in the next video. Bye.